Okay, this is a very difficult question, but it goes through quite a lot of the advanced skills. So before we do it, I'm just going to clear a couple of things up. Let's have a look at Pascal's triangle, because we need that to get the coefficients of when we end up multiplying that out. So here's Pascal's triangle. Let's have a look at the bottom row. The way we label this is this here is the sixth row. Choose the first interesting one. So they're technically labeled as sort of 0, 1, 2, 3. But I think of it as like, there's the first interesting one. We all know the first one is 1. This one is 6, choose 2, etc. And we have a calculator button for that, and we also have a formula. So 6 choose 2 is 6 factorial over 4 factorial, 2 factorial. These two numbers add up to the top. And you can cancel 6 factorial with 4 factorial, because this one is 6 times 5 times 4 factorial. So I can write that as 6 times 5 times 4 factorial cancels. 2 factorial is 2. So that is 15. Okay, but what I'm interested in at the moment is this first one, 6 choose 1. Well, look what it is. Look what it is. 6 choose 1 is 6. 10 choose 1 is 10. N choose 1 is n. Okay, so I'm going to use that. This question has got simultaneous equations written all over it. Find two unknowns given 2 bits of information. So I'm looking to create an equation for that in k and n, and then solve it. So how do I do that? Well, I'm going to multiply this out. I'm going to find the binomial expansion of that and then compare the three terms, the first 3 terms. So let's do that. You multiply this out, you always get the first term to the power. Easy. Then you get always a n choose something, and then the first of these terms and the other term, and these powers add up to n and are descending. So the first one was 1 to the n, and so this one must be n minus 1 and 1, because they must add up to n. And I can choose any number, or any one of these two numbers here, which I'm going to put 1. The next term is, well, can you do it? Everything is going down by 1, so it's n choose something, 1 to something, kx to something. I even put brackets around 1 because I just like it to always look the same. This is just all binomial expansions. So I want these powers to go down, that one to go up, and this one to be the same as either one of those, but why not pick the easier one? Now I've done the first 3 terms. Just need to tidy that up. So what is n choose 1? Well, we've just done that. That's the first interesting term on the nth row. So this is 1 to the n is 1. That is an n. That is a 1. I've got a k and I've got an x, nkx. What is n choose 2 are? So I'm going to have to do a little lemma here. A lemma is when you go to the side and you say, I'm just going to work separately out what n choose 2 is. And then I'm going to come back to my question. So n choose 2, the formula is n factorial over, and then 2 factorial, and the number that adds up to n, so n minus 2 factorial. That will be the same as the 2 powers of the question, n minus 2 and 2. So what is that equal to? Well, again, much like the one I did earlier, n factorial means n times the next one down, times the next one down, times the next one down, etc., all the way to 1. But have a look at this. That bit there is n minus 2 factorial. 2 factorial is 2. N minus 2 factorial cancels the whole of that lot out. and I end up with n minus 1 divided by 2, which I'm going to write like that. So there's my little lemma, half n minus 1. I can come back to my question and now say, I'm going to use that without destroying the flow of my working, half n minus 1. I've got a 1 to something, doesn't matter, that's just 1, and I've got a k squared x squared. Now finally, I can say, I can now match these up. Well, I know that minus 4 must equal that, and plus 15 over 2 must equal that. So let's write those two down. Simultaneous equations, looking pretty horrendous. How do you do difficult simultaneous equations? You take the easiest equation, you rearrange it in the easiest way, and substitute it into the other one. So I'm looking to say, because I've got a choice here, shall I substitute the n or the k? I'd have to square the k, but there's two n's, so I'm going to go for k. K is minus 4 over n. Substitute that in there. I'll just shortcut that. I'm going to put a minus 4 over n in there. Notice I got rid of the minus sign because I'm squaring it. Just thinking ahead a bit. I've got this nice expression here now. I'm going to cancel the 2's, multiply both sides by 2's. Just looking to simplify. I've got 15 equals n minus 1. I've got a 16 there over n squared. You always say to yourself, get rid of brackets, get rid of fractions. 15n squared is 16. Get rid of brackets now. 16n squared minus 16n. Oh, what a surprise. It's a quadratic. I'm going to get 0 equals n squared minus 16n. So n minus 16. N is 0 or 16. N equals 0 is dull. Let's have a look at the question. N equals 0 is dull. And n equals 16 looks interesting. So I find n equals 16. That looks like a good answer. And then I've got a value for k here. N equals 16, k equals minus 4 over 16. So I'm going to cross that one and say n equals 16 implies k equals minus 4 over 16 minus a quarter. Tough question. Love it.